When faced with a square matrix, if we're looking for the inverse of the matrix, in general, what you would do is you would find the adjoint of the matrix and divide it by the determinant of the matrix. And the adjoint is simply the transpose of the matrix of cofactors. And the determinant can be written like that. So that's the general form for the inverse of a square matrix. Now, our question here gives us a square matrix A, and actually gives us the matrix of cofactors, but there are three missing elements, C2, 1, 2, 2, and 2, 3. And the question is asking for a general expression for the inverse in terms of C. And that's exactly what we just wrote. So it's A inverse equals the transpose of T divided by the determinant of A. So that's the general expression. It now goes on to say, find or calculate the missing three entries. So to find C1, C2, and C3, we would need to use the rules for calculating the cofactor elements. So I can look at this. So we're going to use our original matrix, A, but we'll also use a matrix of sign places. So every location will have a corresponding sign. So for example, this matrix, it's going to be positive, negative, positive, negative, positive, negative, positive, negative, positive. And then to find each corresponding cell, so for example, for C21, we would take the corresponding cell in the A matrix and we'd eliminate that row and that column, and we'd find the determinant of the remaining four elements. So it would be a negative sign because C21 in the matrix of place signs is negative, so it would be negative times the determinant of the remaining elements. That's 1, negative 2, negative 2, and 3. And to find the determinant, we simply multiply the diagonal elements and then we subtract the products. So we find the first diagonal product, 1 times 3, and we subtract from that the negative 2 times negative 2. So that gives me 3 minus 4 is negative 1, but then we have a minus sign before that, so it's negative, negative 1, so that's 1. Okay, so this negative is that negative, and that comes about from the position in the matrix. And we can do the same for the next cofactor cell. So C22 would be the same thing, but this time it's positive. So C22, I'll put a positive sign there just to be clear. And again, because we're now looking at this cell here, I'm going to eliminate this row and this column. So the determinant of the remaining elements, 1 minus 2, negative 1, and 3, is simply the product of the diagonal elements, or the difference of the products of the diagonal elements. So we're going to multiply the 1 and the 3. And then I'll subtract from that minus 1 times minus 2. So that's 3 minus 2, which is 1. And we can do that one more time for C23. Again, we've got a minus sign now, so it's minus the determinant of the cells after eliminating the third, or the row and column corresponding to the 0. So that's eliminated. So what you end up with is 1, 1, minus 1, minus 2. And again, all we need to do is multiply the diagonals. So it's 1 multiplied by negative 2 minus 1 multiplied by minus 1. So it's 1 times negative 2 minus 1 times 1. And really, I should have put a pair of brackets around this, because there was a negative sign that I should have been more careful about. So that negative sign is that negative sign. Okay, so back to this. That's negative 2 plus 1, negative. Again, we have a minus sign. We need to be more careful about that. So it's minus negative 2 plus 1. So it's 1 again. So all three cells were 1. So we have C21 is a 1, C22 is a 1, and C23 is a 1. So now we can rewrite our matrix of cofactors C like that, and we can replace the missing elements with 1. So all three of these elements are 1. Now, to find the inverse of A, we need the transpose of C. So what we want is something called the adjoint. So I'll write it out as adjoint of C, which is simply the adjoint of A, which is the transpose of C. And transpose, all that means is every row becomes a column. So the first row, negative 9, negative 6, negative 7, becomes a column. And the second row, 1, 1, 1, becomes a column. And the same with the last. So this is what we call the adjoint of A, or the transpose of C. Now, we still need to find the determinant of A. So we're still a few steps away from the final solution. So let's try to find the determinant of A. So determinant of A, which is also written like this, we can find that by multiplying the corresponding cells of A and C. So I can do that straight from the information given in the question. So I'm going to copy that from the question. And what I'm going to do is simply multiply corresponding cells. So I'm going to multiply the 1 and the negative 9. I'm going to multiply this 1 times this negative 6, and this negative 2 multiplied by the negative 7, and then I'll just add them together. So the determinant of A is 1 times negative 9 plus 1 times negative 6 plus negative 2 times negative 7. So that's negative 9, negative 6, that's negative 15, plus 14 is negative 1. So that's really good. Now we've found the determinant, negative 1. Remember the original formula, the expression they asked for. To find the inverse of a matrix A, we take the transpose of the cofactors and we divide it by the determinant of A. Now we know that the determinant of A is negative 1. So we simply replace. So basically we're going to divide the matrix that we found in our first part up here. We're going to divide that by negative 1. And dividing a matrix by a constant simply means dividing each cell by that number, and in this case we're just going to change the signs because you're dividing by minus 1. So 9, 6, 7, negative 1, negative 1, negative 1, 6, 4, 5. And there we have our answer. That's our A inverse. So the question asked for the inverse of A, and we've just found it. But the question goes on to say, check your results by calculating the first column of the product. Now, what does that mean? What do we expect the product to be? So when you multiply any matrix by its inverse, you're expecting to get the answer 1. So the 1 in matrix language is simply the identity matrix, I. And the identity matrix is simply a set of elements where 1 in the diagonal and all the other elements are 0. So that's what we're expecting. We're expecting a matrix that looks like this. And the question is asking us to check our answers by calculating the first column. So if we multiply A by A inverse and we get 1, 0, 0 in the first column, we will have satisfied the question. So let's take A and multiply it by A inverse. So A from the question is this matrix here. So I'm going to multiply that by the inverse that we just found. And remember, when you multiply matrices, you need to multiply the row by the column. So it's a bit of work involved, but let me do that element by element here. So you've got the product of these two matrices, and because they're both square matrices, then the product will also be a square matrix. And there should be these three elements that we're trying to find. Okay, but it will be a square matrix. So if we look at the first element here, the one that we're trying to find, then it should be the product of the cells of the first row in A multiplied by the cells in the first column of A inverse. All right, so this element here, this matrix here is A, and this matrix here is A inverse. So we're going to multiply each cell by the corresponding cell. So what goes into this cell here is going to be the product of 1 times 9 plus 1 times 6 plus negative 2 times 7. And we're hoping the answer is going to be a 1. So 9 plus 6 is 15. Take away 14 is 1. So that's a win. That's what we were expecting. So that's our first cell. Let's look at the next cell, this one here. And again, we're going to multiply the second row times the second column. So we're going to multiply these cells. I'll just put them in a different color. There. So we're going to multiply these. And again, it'll be multiplied by this same column. So we're going to multiply the 2 times 9 and the negative 3 times 6 and the 0 times 7. So that's 18. Take away 18 plus 0 is 0. And again, that's exactly what we were expecting from the identity matrix. So we put the 0 there. And finally, we're going to multiply this last row by the same column. So that's this cell here. And that's going to give us negative 1 times 9 plus negative 2 times 6 plus 3 times 7. So that's minus 9 minus 12 is minus 21 plus 21 is 0. And again, that's what we were expecting from the identity matrix. So we could carry on and do the whole identity matrix, but the question is asking us to check using the first column. So we've checked and that's worked okay. So we've found the 3 parts of the question, and most importantly, we've inverted A. We've managed to find the inverse of A. So that's how you would approach a question like that.